Hello everyone, today we are doing our third round of notes here. This is all about vertical angles. So you hear me say that word vertical angles a ton. Today we're actually getting back into math. So it's not a ton of proofs for right now. We're gonna do a ton of math and I'm gonna bring up some concepts back from Algebra 1 as well. So if you don't have a calculator, maybe go pause this video, grab a calculator and come back. All right, up first, we're gonna name all the linear pairs. Now remember, there's two things that make a linear pair. They have to be next to each other. All right, and they have to add to 180. They create a perfectly straight line. All right, so see if you can pause this video quick and see if you can name a few of those linear pairs. I'm thinking, hopefully you paused and wrote some down. I think that angle 1 and angle 2. All right, those two angles right there, if I shade them in, those are definitely next to each other. They definitely add up to 180 as well. I think that angle 4 and angle 3 are a linear pair. Angle 4. Angle 3. They're next to each other, they add up to 180. Good to go, linear pair. I think there's two more sets in there. I think angle 1 and angle 4. Angle 1, angle 4. And I think angle 2 and angle 3 are a linear pair as well. Awesome. All right, up next it says name all the vertical angles. Remember, vertical angles are ones that are across from each other. All right, so I say that angle 1 and angle 3 are vertical angles. I also think that angle 2 and angle 4 are vertical angles as well. So we're using those terms quite often today. All right, the vertical angles theorem. All right, this is now going to become a reason in our proofs as well. The vertical angles theorem says if two angles are vertical, then their measurements are equal. So all that means is that vertical angles are actually the exact same measurement. So angle 1 is the same measurement as angle 3. Angle 2 is the same measurement of angle 4. They're equal to each other. That's going to help us solve for a lot of missing angles. What we're going to do real quick is we're going to do one example of a proof just to prove this theorem, and then we're good to go. All right, it says angle 1 and angle 3 are vertical angles. Well, yeah, angle 1 and angle 3 are vertical angles. And our goal is to prove that they're the exact same measurement. We're going to prove this theorem true, all right, using other things that we know. So our first thing, our first statement probably should be our given. So I've got angle 1 and angle 3. I shorthand this to VA, are vertical angles. My reason here is given. All right, the second thing says the definition of a linear pair. All right, definition of linear pair. Look at that, I'm looking for a linear pair here. I think, remember, angle 1 and angle 2 were a linear pair. So I'm going to say the measurement of angle 1 plus the measurement of angle 2 equals 180. Whoops, sorry guys, my dog is currently jumping on my lap here. Okay. 180. All right, what I'm gonna do here, if I find another linear pair, I'm gonna say that the measurement of angle 2 plus the measurement of angle 3 equals 180. I'm gonna say definition of linear pair. And so those two equations are equal to 180, so we set them equal to each other. The measurement of angle 1 plus the measurement of angle 2 equals the measurement of angle 2 plus the measurement of angle 3. All right, that's transitive or substitution, whichever one you want to use there. All right, and remember, my proof is the measurement of angle 1 equals the measurement of angle 3. And how I do this, I subtracted the angle 2's from both sides, so it'd be subtraction. Awesome. All right, so we've proven this. We're good to go. We can use this as a reason from here on out. So we're actually using some math here, like I said. So we're going to be solving for all the missing angles here. All right, using vertical angles. So if you look at problem number 1, where you got to find angle 1, we got to find angle 2 and angle 3. And all we are given is this angle right here. It says it's 40 degrees. Now that we know that, what angle do we automatically know? You're right. We automatically know that's vertical angle, angle 2. This is 40 degrees. Awesome. How do you think we could find angle 1 and angle 3? Hopefully you're noticing, well, these two angles right here, well, they're linear pairs, which means they should add up to 180. So I can do 180 minus 40. And I'd get 140 for angle 1, which means because of vertical angles, angle 3 is 140 as well. Perfect. All right, angle 2, it says that our first angle here is 2x plus 40. So this angle is 2x plus 40. And that this angle here is 5x plus 16. So we have to figure out what type of angles are those. Do you think those are vertical angles, or do you think they're linear pairs? I think they're vertical angles, which means if they're vertical angles, which means they equal each other. So I can say 2x plus 40 equals 5x plus 16. Let's solve for x here. I would subtract 2x from both sides. Okay. I'm going to subtract the 16 from both sides there. I'm going to divide by 3. And I get that x is 8. But is that what we wanted to find? No, we're wanting to find this angle here. How are we going to find that now? Yeah, we're going to plug in 8. So I have here 2 times 8 plus 40. All right, 2 times 8 is 16. 16 plus 40 is 56. How are we going to find that missing angle then? You're right, we could do 180 minus 56. What is 180 minus 56? 124. Awesome. All right, last example here. I'm going to zoom in kind of. All right, we've got that this angle right here is 6x plus 8. And that this angle right here is 2x minus 2. So we gotta figure out what type of angles are those. Are those vertical angles, or are those a linear pair? Those are a linear pair. We know that linear pairs add up to 180. So our equation is going to be 6x plus 8 plus 2x minus 2 equals 180. We're going to have to do some math here. All right, I'm going to combine like terms here. 6x plus 2x is 8x. 8 plus a negative 2 is a positive 6. And that equals 180. All right, I'm going to say that we're going to need to subtract that 6 from both sides. So I've got 8x equals 174. I'm going to divide by 8 on both sides here. All right, and that's going to give me decimal, and that's okay. I get x is 21.75. Oh my goodness, yes, I'm sorry. My dog is completely walking over me at the moment. I think she's mad that I'm not paying attention to her. All right. We're going to do 2 more examples here. So I'm going to take you back to Algebra 1 land here. I'm going to really make you think back. I'm going to help us through these problems, but it's something that I kind of expect us to be a little good at here from previous years. So this one, if you look at angle 4, or example 4, you'll notice that we have a lot of variables. We've got an x and we have a y. So what we're going to do is we're going to have to solve what we call a system. All right, a system of equations or 2 variables here. All right, there's a couple different ways we can solve them. There's 2 main ways. We can either use substitution, or we can use elimination. I'm a big fan of elimination, but I feel like most kids usually like substitutions. I'm going to show you those examples. Now, when doing systems of equations, we have to write out 2 examples ourselves. We have a lot going on here. When I'm looking at this, I think that this 3x plus 2y and this x plus 10y minus 4, I think those are vertical angles. And I know that vertical angles equal each other, so I'm going to write that out. I'm going to say 3x plus 2y equals x plus 10y minus 4. Okay, and what I'm going to do is I'm going to kind of move all the variables to one side so I can count them all together. So I'm going to say that I'm going to subtract that x over, and I get 2x. I'm going to subtract that 10y over, so I'm going to get negative 8y. That equals the negative 4. Okay, so there's my first equation. Since we have 2 variables, we actually need 2 equations here. Okay, so when you think of some other equation from this picture, when I'm looking at this, I'm like, well, I think that this 3x plus 2y and this x plus 6y minus 4, those look like a linear pair, which means they should add up to 180. So I can say 3x plus 2y plus x plus 6y minus 4 equals 180. Let's combine some like terms. I've got 3x and x. That gives me 4x. I've got 2y and 6y. That gives me 8y. All right, I've got that negative 4. I'm just going to add that over so I get 184. Awesome. So we've made two equations here. Okay, the reason we had to make two is because there's two variables. Now what we're going to do is, I'm going to show you an example of substitution, which is when you solve for one of the variables and you plug it into the other equation. So let's look at our yellow equation over here. 2x minus 8y. I think it'd be pretty easy for us to solve for x. All right, so if I wanted to solve for x, I'm going to add that 8y over. So I've got 2x equals negative 4 plus 8y. I'm going to divide by 2, and I get x equals negative 2 plus 4y. What I'm going to do with this is I'm going to take this information right here, this negative 2 plus 4y. I'm going to replace every single x I see in my other equation with that negative 2 plus 4y. So I'm going to say 4 times that negative 2 plus 4y plus 8y equals 184. And we're going to solve for y. I'm going to distribute that 4. So I get negative 8 plus 16y plus 8y equals 184. All right, I'm going to combine like terms here. So I've got negative 8. 16y plus 8y is 24y. I think we need to add that negative 8 over. So I'm going to do 184 plus 8, and that gives me 192. I'm going to divide by 24 on both sides, and that's going to give me that y equals 8. Now that I know y, I can plug it into any equation I want and get x. What I'm going to do is I'm just going to plug it in right over here. So this equation when we solved for x. So I'm going to say that x equals negative 2 plus 4 times y. We just found out that y is 8. So I've got x equals negative 2. 4 times 8 is 32. Okay, and I see that x got equals negative 2 plus 32, which means that x equals 30. All right, so you can write it just like that. You could also write it as an ordered pair, 30, comma 8. All right, I'm going to be very flexible on either one. My idea is if you can get to this point where you have both variables, I'm extremely impressed. All right, the other way is elimination. That's kind of my favorite way too. I'll show you guys an example of that in class as well so you can kind of see both. Whew, it's a lot of work, right? A lot of work for one problem. All right, last one here. All right, we've got that all of our angles here. We have two angles again. Whew, so we're thinking we're going to have to do that whole big crazy thing again. But if we're smart and we choose the right angles, all right, we may not have to. So let's look at the angles that have y in them. I've got 10y right here, and I've got 3y plus 11. Do you think it's possible for us to write an equation with those two angles? I would say yes. Reason being, what type of angles are those two angles? They're a linear pair, which means they would add up to 180. So I can say 3y plus 11 plus 10y equals 180. I've got 13y plus 11 equals 180. I'm going to subtract that 11 over. So I get 13y equals 169. I'm going to divide by 13, and I get that y equals 13. Okay. There's a couple different ways I could solve for x here. All right, I could plug things in. So I'm going to show you just in the way. I could make an equation also, guys, to solve for x. I could say that 7x plus 4 plus 4x minus 22 equals 180 and solve for x. I'm going to show you a different way to kind of attack problems. So there's a ton of different ways we can solve things. I'm going to plug that y value in. So 10 times y, which is 13, is 130. If that's 130, that means that this one's 130. It also means that this one's going to be 50 degrees. All right, so we can do a couple different things here. We can set an equation. So we could say 4x minus 22 equals 50. I could add that 22 over, and I get 72. I can divide by 4, and I get that x equals 18. I could also do the same thing. I could have said that 7x plus 4 equals 130, and same way I've gotten the exact same answer. So there's tons of different ways we could find these answers. So if you do something different, that is totally okay. Come to questions for class, or come